Welcome to topic 3 of scripting for security. And in this topic, we're looking at 3 subtopics, and those are Unix and Linux shells, written with a little star there, Windows shells, Python, and regular expressions. So, first of all, Nix shells. So Nix, if you see this star Nix, it means like Unix or Linux, anything that ends Nix. Okay, right. First of all, what is a shell? So a shell is a user interface for access to an operating system services, and it is named as a shell because it is the outermost layer around the operating system. So CLI shells, or command line interface shells, where we type commands to the computer, require a familiarity with commands and their syntax. So you can't just jump in to, say, a Cisco router into the Cisco IOS and start clicking around with your mic. Because if you're not familiar with the commands and their syntax, things like show IP route, then you're going to have some difficulty using it. So you need to have an understanding of a shell-specific scripting language or of some commands that shell understands so that you can talk to the computer, or what's likely most importantly, so the computer can talk with you or talk back to you. And there is an old saying that you'll hear people say that they're like, oh, ask him because he knows about computers or he understands computers. And I often think it should be the other way around. It should be ask him because computers understand him. Not he understands computers or she understands computers, computers that understand the person. So POSIX compliance is a standard for interoperability. Now, I've added a couple of explanations here of POSIX compliance of varying degrees of quality. So this is the IEEE standard for POSIX compliance. And it says here that it's a standard operating system interface and environment, including a command interpreter or shell and common programs. Okay, so it's a command line shell standard, all right? And there's a useful article I've put here by Richard Stallman, the leader of the Free Software Foundation, where he explains what POSIX is. Okay, so part of the kind of free software standard. Now, GNU Bash, all right, or the Bash shell, was created by this chap at the top here called Brian Fox. And he's a very fun guy. You should have a look on his Twitter or his social media or his website. I've had a look into him, and he does some quite interesting stuff, especially around like cryptocurrency and stuff. He's a very, very clever guy. So he created the Bash shell for the GNU operating system, and the Bash shell is commonly found and used. And until 1994, he was in charge of it when it was transitioned to this chap, Chet Ramney. All right, and down here we have, that's not Chet Ramney, that's Richard Stallman down at the bottom there. He's the leader of the Free Software Foundation. So another shell, different from the Bash shell, is called the Amquist shell. Okay, now this is sometimes just known as ASH. So ASH, short for this name and shell, ASH. All right, now ASH is an alternative shell to Bash. And the reason that people use ASH is because it's much lighter. Dash is the Debian ASH shell. So what I'm going to do is I'm going to run the command, okay, echo $shell. And this will tell me what my default shell is. Now, me as in this user, Michael. And when it says bin bash, the bin directory is actually a binary folder where programs live. So for example, the ls program, right? ls for list is actually stored in the binary folder, okay, bin ls. So bin bash, so my default shell is the bash shell. So if I cd to /bin, okay, now there's quite a lot of items in /bin, as you can imagine. It's all the stuff that's on the system. So I want to look for things that are shells. Let's have a look for dash. I suppose I should probably have just sorted it in alphabetical, right? Dash, dash, there's dash there. Debbie and Ash. Okay, so that's a different shell that I have on this system. And dash is actually used to start up the operating system. Dash is in user bin dash, whereas bash is in user bin bash. Okay, so two different shells on the command line. Now, the dash shell, okay, is much lighter than the bash shell. And so commands that are created to run in the ash shell might not work in the bash shell and vice versa. So how do we ensure interoperability between them? The answer is we need to make shell scripts posix compliant. All right, that's this thing that we had back here. Okay, posix compliant. So that's what that standard is for, interoperability between different shells. First of all, let's do dash -c, okay, and then I'm going to say echo the command hello. Dash is replying with hello. Now, if I change that to bash, it's replying with hello. Now, we can run, now, if I were to do cat/bin whereas /bin/sh, user bin sh. This is the default, okay? So if I do man sh, we'll see that the default shell sh on the system is actually dash, okay? Interestingly, so if you were to create a script and run it, and you put at the top of your script, I'll show you how you do this, okay? So when we make a script on a system, right, I'm going to make a new script just now, okay? So here I'm in VI. So at the very top of the script, I'm going to tell the operating system which shell to use, okay? And what I'm going to do is I'm going to do hash bang, okay? That's called hash bang. It's a hashtag and an exclamation point, all right? Americans call this hash bang. So hash bang /bin/sh, okay? If I do that, what I'm doing is I'm telling the operating system to select the default shell on the system. So it's quite common to write something, and quite common that you'll see hash bang /bin bash, okay? But the problem is not every operating system has the bash shell, okay? So some operating systems might have the ash shell, some might have the Z shell, some might have the K shell, some might just have this sh and it's mapped to something that we don't know, okay? So if we use this bin sh, it's going to use the default shell. And if we make sure we write the script to be POSIX compliant, then we are definitely going to ensure that the script will work on multiple different machines. Okay, so always specify the shell that you want to use at the top. And we do that by doing this hash bang bin bash. Now, interestingly, if I just come out of here, okay, I can run. So running it with the dash shell, okay, running it with the default shell, which we know is mapped to dash. Now, I can run any shell here, right? So Python has a shell as well. So if I were to change this to Python -c, okay, it's going to give me an error, okay, because of, oh, hold on, Python 3, right, it's giving me an error. And why is it giving me an error? Because the Python shell doesn't understand echo, right? The Python shell understands print, okay, and probably have to put these in quotes here as well. And we probably have to put that in quotes there, which is probably going to break those, but let's try this, and this should work for Python. There we go. So we can send commands using this -c directly to the shell that we want by doing this. And we can access the Python shell just like that. There's the Python shell down there, okay? 2 + 2 will return us 4. Okay, so this topic is on Python regular expressions. Regex, RE, rex, regexp, all mean the same thing, okay? So first of all, what is regex, or what is a regular expression? So a regular expression is a pattern, a set of characters that specify a search pattern, okay? So usually such search patterns are used by string searching algorithms for find. So when you're using a notepad document and you do Control F and you type in a word you want to find on a page or something like that, in the background, this is running a regular expression. Okay, now I can give an example of some regular expressions. Let me just get out of my Python shell here. So let me just run a command. If I were to run the command IP address show, okay, IP address show, it's going to give me all this output here, loads of output. Now, my IP address is actually 192.168.0.14, okay? So let's say I wanted to specify a pattern, or I wanted to say, you know, okay, I've got all this output, or let's say this was hundreds of lines of output, and I wanted to somehow specify a pattern to return. I could do that here. So let's do IP address show. And what I'm going to do is I'm going to use a pipe symbol. So I'm going to pass the output of IP address show to another program, okay, like connecting two pipes together. And the other program I'm going to use is called grep, okay, and that stands for Global Regular Expression Patterns, or sometimes Get Regular Expression. Okay, then I'm going to specify inside these quotes what pattern I would like to be returned. And what I'm going to do, okay, is I'm going to say inet. Okay, so what's actually happened there is I'll show you all of the lines first of all. Okay, there's everything that's come out. What I'm saying is, just give me lines that start with the word inet. So we're getting this one, we're getting this one, we're getting this one. Okay, so let's just run that one more time. So that's given us this here. Now, if I only wanted the, let's say I only wanted the lines that started with inet 6, I could do inet 6, and look, it's only given me these inet 6 ones here. Now, interestingly, okay, I could pass this to, so there's our grep, there's the output of grep inet, right? I could pass this, connected a pipeline, I could pass this to another instance of grep, and this time I could use an inverse pattern. So I could say, right, -v, okay, which means like inverse, right? Give me all the things that do not start with inet 6. Let's see what happens here. Okay, so now that's only giving me the inet numbers. All right, I'll run that again clear so you can see it. So I'm saying IP address show, get regular expression starting with inet, then get regular expression doesn't start with inet 6, is giving me these 4 lines here. Okay, now what I could do is I could say using the head command, all right, so let's pipe this into head and give me only the top 2. So now I only have these 2 here. And let's say I could use the tail command to give me only the last one. Now I have only the line that I want, okay? Now we can keep piping this into other commands. So let's say I only want this here. Okay, I can pass this to another program called awk, and we can say to awk, okay, awk, print me only the second column, so $2. All right, so that's only giving me this. Now we're down to that. So let's just clear. So that's the command there if you just want the IP address of that particular interface out. And this is a way that we're filtering through, okay, using these two regular expressions. So we can do these on the command line. We can actually do these in every language. But what we're going to look at today is how to do it with Python. In order to use a regular expression in Python, we're going to import a module called RE. Okay. Now, Python has a built-in package, and RE just stands for regular expression. So to import this, all we do is we type import RE. Now, I've created a string here, okay, called "They speak French in France." And what I'm going to do is I'm going to use a regular expression to test to see if that ends with the word France, okay? So what I've done here is I've created a variable called x, all right, over here. And I'm saying, okay, inside x, use this RE module and use a function of the RE module. So we're going to use a function, that's why we've got these brackets, called search. And then we are going to search this txt here. We're going to send that in as a parameter here. Okay, and the search we want to make is in these quotes here. Okay, and we want to say this dollar means the end. So we want to say any characters and then France is the end. Okay, ends with France is what that means. And that's how we have a match. They speak French in France as our test string. And then we're going to use RE, our module, and we're going to search for France txt in txt. Let's run this and see what happens. All right, I've got print. We're going to print x at the end. So let's run this with F5. Okay, so what's happened is, all right, this has found a match object. Match equals France. So let me run this again. Okay, so it's saying match equals France. It's found a match. Now to show you when that doesn't work, I'm going to change that to France, right? And let me just run that. Okay, so it's now saying none. Okay, it doesn't have a match. Inside RE, the module, there are different functions. There's search, which I just showed you. There's find all, there's split, and there's sub. I'm going to show you an example of each of those working just now. So first of all, find all, re.findall. So re.findall will return a list containing all matches. All right, so let's open this up and have a look at re.findall here. We are going to do re.findall for the letter Z in txt. So let's have a look and see what happens. Now, we know that there's no letter Z in here. So let's just run that. Okay, so it's returned an empty list. Now, let's say we want to look for a letter that we know is in here, okay? We know that there's letter E's in there. So let's change that to the letter E and run. And look, it's returned 4 of them here. There's 1, 2, 3, 4, okay? So that's how we use re.findall to find a pattern. Now, look, if we put EY, we've got an EY here, right? Let's put EY, okay? And run. Okay, it's returned 1 EY because there is 1 EY. Now, we can even be a little bit more specific with the pattern we want the computer to return. So let's say we want something P, something A. Okay, so dot A. Let's run that. Okay, so it's found a match, right? This dot here means any character. Any character. So we're looking for a pattern where we have the letter P, any character, and an A. Okay, let's change this. We're looking for a pattern which has the letter F. Okay, then 1, 2, 3, 4 letters, then an H. All right, so letter F, 1, 2, 3, 4 letters in H. Hopefully it should find the word French if we do this and return it in a list. Okay, let's run that. There we go. It's found French because French matches the pattern of F search, re.search. So we're going to use re.search in combination with a function called x.start here. So let's go for re.search. Example 3, right? re.search on they speak French in France. So we're searching for a letter H and we're going to x.start. We're going to count where the position of that H is with this example. Let me comment out example 2 there and run this. Okay, so it said the first match, the first character is in position 1, and right enough, that is there. So if we change that to T, okay, it's going to say it's in position 0 because it starts at 0. Okay, so let's find the first instance of N. Let's just put N in there, run it. Okay, it's found N in position 14. So that's re.search, returns the first match. Okay, split will return a list at the split for a match. So we can actually split our string in half wherever at a point, at a pattern that we specify. Okay, so they speak French in France and we're going to split. Now, here's something interesting. I'm saying split on S, but I'm not literally saying S, okay? So what we have is we have characters that can actually have 2 meanings, okay? 2 meanings. So when we put this slash before here, that's called an escape character. And we actually escape from S and give this a second meaning. And that actually means /S means space. So what we're saying here is regular expression module, split function, find a space in here and split the string up. All right, so I'll show you what that looks like just now. Let's run that. So what it's done is it's taken our input string and it's returned a list split at every single space with every item in the input string as a separate list item. Okay, we can change what it splits on though. For example, here I'm going to split with the letter E. So it should split here, split here, split here. So let me show you what that looks like. Okay, split. Let's run this example. Okay, so look, it's th, e, sp, k, fr, t. It's chopping it up when it finds the letter E there. Okay, so that's re.split. The final example is sub. Sub's just short for substitute. Okay, so in the first example, I'm going to show substituting the letter F for the letter P. So they speak French in France. I'm going to find every instance of the letter F capital and swap it with an instance of the letter P. So let's have a look at that in action and run. So there we go. Let me just comment away this print statement here as well, tidy things up a wee bit. Okay, so there we go. That's returned. They speak French in France. Okay, they speak French in France because I've said find every letter F and substitute with a P. So the next example I've put is find every space and substitute with the word Italy. Okay, so if I run that, it says they Italy speak Italy, French Italy, in Italy, France. Okay, so that's how re.sub works. And here's a list of some other characters that we can use in our patterns. So I already showed you the bottom one here, /S for space. A set of characters is in square brackets. An escape character we can do with the slash, as I showed you. Dot is any character. Dollar is ends with. And this is not a full list. There are more special sequence characters available and meta characters. So where can we apply this to security? Well, let me say that there are examples of regular expressions online that you can easily take and adapt into your scripts. For example, I have two here. So this regular expression in re.findAll, okay, will let us find an email address. And the way it does that is, okay, if you imagine, here's re.findAll function, all right, these brackets, and then there's our input text, all right, and here's our text up here. So we're going to send this message in, hello from bigmick@gmail.com to weejimmy@yahoo.com about the meeting at 8 p.m. at 192.168.100.3. That's our input text. And we want to search that, giving it a regular expression pattern to return only email addresses. And inside our quotes here, we have placed a set, right? So this is a set of characters, and we're saying, give me anything that's A to Z, capital A to Z, 0 to 9, underscore dot plus or minus. Then give me the @ symbol. Then the same again. Then the same again. So this could be like .co.uk or co.au or co.com. This will match any email address. And underneath, I have another example with re.findAll that will find IP addresses. So we're looking to try and find this inside the input string. And the way we do that is a /d means a number. So what this is saying is, this little group here in the curl brackets is saying 1 or 3 numbers. Okay, so it could be 1.1, it could be 1.1.1.1, or it could be 192.168. Okay, so let me just show you those in action. I've got an example running here. So here's that example I showed you on the slide. And first of all, let's search that string to try and pull out this email address using that regular expression X. Okay, so let me just search that now and run. So you'll see, look, that's returning a list with just email addresses in it. And let me search for just IP addresses, and you'll see that that's returning a list with just IP addresses in it.